Welcome to another session of INF154. So for this session, we are going to go through loops. So this will be the last video for this semester. Unfortunately, I won't be doing more videos. So yeah, this is the last video. The fortunate part is that loops are easy. So they are not that difficult if you understand them properly. So from the previous lectures or sessions, we know that we have three types of control structures. So we have the sequential logic. So in the sequential logic, the code is executed sequentially, line by line from top to bottom. So this is the general flow chart. You start, then you get the inputs, then you execute statement 1, statement 2. You can have as multiple statements as you want. Then you go to the output, then you stop. Notice with this type of logic, we cannot skip, we cannot repeat a certain code. If we wanted to repeat statement 1, we were going to write underneath statement 1 the same code again. Then this was lecture 1 up to 3 from your lectures. Then we have the selection. So with the selection, you have choices. So certain statements or code is executed based on some condition. So the general flow chart, again, you start, then you get the inputs. Then if the condition is true, you choose a path. Then if the condition is false, you choose another path. Then you get to the output. Notice that with selection, you just have to choose a path to go to the next instruction. So we did that in the previous video in detail. So if you forgot how to do that, you can watch the previous video, but it was only theory. I didn't get time to do the problems. Then we have the last control structure, which is repetition. So this is the most important one for programming. So this is going to be used on INF164 and on 272 again. Then with the repetition, we are going to repeat a certain code a specific number of times. That's the goal. The goal is to repeat. So the flow chart, you start, you get the inputs, then you go to the condition. So the condition, again, is your Boolean expression. It can either be true or false. If the condition is true, then we execute like a statement. Notice here, we execute a statement, then we go back to the condition. So we test the condition again, then we go to the statement. If the condition is true, then we just repeat until this condition becomes false. So until the condition is false, that's where we can stop executing the code. So if the condition is false, then we can choose the false path, then we can continue with our code until we reach the end of the program. So that's repetition. The difference is that here you execute like certain code, but after, like, if the condition is true, you execute the code, then you update the condition, then you test that condition if it's true or false again. If the updated condition is true, we repeat the same process. Execute S1, update condition, go back, then test the condition. If the condition is false, that's where we can go out. We'll see how it works in detail. So that's the basics. So how are the lessons going to be divided? So the loops, they are very important because in the exam, I think they will take almost half of the marks. So it's a very broad topic. So we are going to cover list boxes, introduction to loops, the properties of loops, while loops in detail, which include counter, control while loops, and sentinel while loops. And we are going to cover infinite loops, then problems using the while loop, then the for loop, nested while loops, nested for loops, advanced problem solving with loops, timers or timer as a repetition structure, then more problems. So in this video, I think I'm going to cover the first 3 important parts. So I'm going to cover the first 3 important parts. Then the rest will cover them in person. Yeah, the rest will cover them in person. I won't do videos, I think, for the rest. Then we are going to start with the list box control, which you did. So a list box control is a list of items. So it stores a list or a sequence or an array of items. So in Visual Studio, we have it's represented by a box. That's your Visual Studio. But in memory, it's represented by that box. But within that box, you have like lines, sort of imaginary lines. So imaginary lines. So sort of blocks. So in the first block, you store the first item. In the second block, the second item. Third block, the fourth item, and so on. So it's just like a block of memories where you store items. So when you say items, then you open bracket, close, then 0 refers to the first memory block. Then when you say items 1, it refers to the second. If you say items 2, it refers to the third. If you say items 3, it refers to the fourth. Items 4, it refers to the fifth, and so on. So when you say items, then you put the square brackets, then 0, the index. You are referring to a certain memory block. So you are going to understand the syntax when you get to arrays. So how do we add items to a list box? Adding items to a list box is straightforward. So when we say lst numbers.items.add 3, so initially this was empty, it's going to add 3 to the first available space. Then if we add again 10, it's going to add 10 to the second available space. Then again, you put lst, then the name of the list box .items.add. We are adding items. That's why we are saying items, because this list box is a list of items. Then we are adding, then lst numbers.items.add, then 40. We are just adding. So the final list box in Visual Studio Code, it will be that box and the added numbers. But in memory, items 0 will refer to this 3. Then items 1 will refer to this 10. Items 2 will refer to this 30. And items 3 will refer to this 40. That's how it works. Then how do we access an item? Yes, we can add items, but what if I want to access an item? So what if I wanted to access 10? So the general syntax of accessing an item, it's lst name dot. So you are going to say the name of the list box dot items. Then you remember that those square brackets, now you use them. Then you put the index, where the index is the position of your item. For example, if we want to access 10, we are going to say lst. In this case, then the name is lstn. So we are going to say lstn dot items. Then we are going to put square bracket 0. So it's dot items 0. It's going to return 10. But 10 is not an integer. 10, the returned 10, it's not an integer actually. If it comes from the list box, it's an item. So we have to convert to an integer. If it was a string, we were supposed to convert to a string, and so on. So this is an example. If then you say convert to int32, then what are we saying? lst n dot items, then we put the index. So in this case, we are saying 0. If that is equals to 40, then we are going to say message box dot show hello. So what is lstn dot items 0? So lst n.items 0 refers to this, which is 10. So that 10 is converted to what? To an integer. So we are going to have 10 as an integer. Then we are going to compare it with what? With 40. Is 10 equals to 40? No, 10 is not equals to 40. So we are going to ignore this. We are going to execute the else part. So it's going to output world instead. So that's the basics of how to access an item. You will see that it's very important to know this. Then how do we get the number of items? So given a list box, we can actually get the number of items. So there's this lst name.items.count. So .items.count counts the number of items. So it returns the number of items in the list box. For example, here we have a list box called lst_num. So if we say lst_num.items.count, this is going to return 5. It's going to count the number of items. So we have 1. Yes, when we count, we start from 1. This is proper counting. When we are counting, it's 1, 2, 3, 4, 5. But when we are referring to the indices or the index, we start at 0. When we're referring to the positions, we start at 0. But when we are counting, we count from 1. So this is 1, 2, 3, 4, 5. So we have 5 items, because it doesn't make sense to say 0, 1, 2, 3, 4. Then you say you have 4 items. So be careful. This 0 refers to the positioning or to the index. Then 1 refers to when you are actually counting the number of items. So those are the basics. So just know that lst_num.items.count returns the number of items in a list box. Then another theory or another important thing before we can go to loops, which you covered in lecture 5, it's your prefix and postfix expressions. So when we use repetition statements, we often need a counter to check how many times something is repeated. But we are not here yet. So we have two expressions. We have the postfix. In the postfix, we have the post increment, then we have the post decrement. So for the post increment, it comes from the word increase. Decrement comes from the word decrease. Then post is after. So post increment, we are increasing after. Post decrement, we are decreasing after. So we know this x equals to x plus 1. The shorthand is going to be x plus equals to 1. But we are very lazy. We can shorten this to x plus plus. So this is the same as x equals to x plus 1. We are increasing the value of x plus 1, by 1. Same with the decrement, x equals to x minus 1. We can rewrite this using the shorthand, which we did cover, which is x minus equals to 1, or we can be more lazy and say x minus minus. So this increases the value of x by 1. This decreases the value of x by 1. So, but let's see how it works. So int a equals to 2. So initially our a was 2. Then we say a plus plus. So the final value of a after this expression will be 3, because we are increasing a by 1. So if we say int b equals to 2, then c equals to 3, then we say sum equals to b plus 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 c plus plus. So this is very tricky. So this is very tricky. Even if you go to people who did IT at school, they will actually get this wrong, because it's very tricky. So when you say sum equals to b plus 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 c plus plus, so this is a post increment. You have the plus plus after the b. So when you say b plus plus, the value of this expression, not the value of b, will be 2 plus plus, which is 2. So it's a little bit tricky. Then C++ it's 3 because the value of C is 3. Then when you say C++ it's 3 because this is post. So after evaluating 2, it's going to increase the value of B to what? To 3. Then after evaluating C++, which is 3, then it's going to, it's going to increase the value of C by what? By 4. But here, when we say B it's 2. Then plus C, which is 3. So it's going to be 5. The sum is going to be 5. But the value of B is going to be 3 and the value of C is going to be 4. So it's a little bit confusing, but you guys don't bother much about this. Just know that plus plus increases the value of A by 1 and minus minus increases the value of A by 1. Then we have the prefix expressions. So we have the pre-increment and the pre, so this is the pre-decrement. So this one, it's straightforward, it's the straightforward one. This one is not confusing like the previous one. So here we are increasing before, so it's the same. It increases the value of x or whatever by 1, decreases the value of x by 1. So for example, a equals to 3. If we say plus plus a, it's the same as 4 because a was 3, then it's 4. Then again 2 and 3. If we say sum equals to plus plus c, this is pre, it's going to increase first the value of c by 1, so it's going to be 3. Then again it increases the value of d by 1, which is 4. Then the result will be 7 as expected. Then we have 3 plus 4, which is, the final value of c is 3, then the final value of d is 4. Then this one does the same thing, but it decreases the value of whatever by 1. So just know the difference between, though it's not necessary actually to know the difference between the post and prefix. It's not that important, but just know that plus plus x or x plus plus increases the value of whatever x by 1, and minus minus x and x minus minus decreases the value of x by 1. You just have to know that. You don't have to know this crazy theory, but there is like some crazy theory behind this, but you don't have to know the crazy theory. Now we can go to loops. So we have 3 types of loops. So we have the while loop, then we have the for loop, do while loop, for each loop, nested loops. Then I think for 154 you are going to do the while loop, for loop, and the for each loop. Then this one you won't do it actually, and nested loops of course. The for each loop, yeah, maybe if you want to use it here, this means you are going to use it in 164, but you are going to use it somewhere. But this one, I don't know why, but you want to use the do while loop. So we know that we have like these types of loops, but all these loops have the same, have a common task, which is to repeat, and they have like these 4 properties. So if your loop is missing any of these properties, then there's something wrong with your loop. So you must have the initialization, you must have the condition, then you must have the task or the do something, then you must have your update. So this is the general properties of all the loops. The for loop follows this, the while loop follows this, for each loop, nested loops, they follow the same pattern. So if you know one loop, then it's easy to switch to another loop. It's like your if statements and your switch statements. If you know if statements, it's easy to switch statements, and if you know your switch statements, it's easy to switch back to if statements. So it's sort of similar. So it's a matter of which loop you prefer, but for your tests you have to know how to use these two loops and obviously the nested loops. So when we start, this is the flow diagram. So with loops, when we start, this is the general flow chart. So we start, we get to the condition. Then we ask ourselves, is this condition true or false? If the condition is true, we are going to execute a task, and we are going to do what? To update our condition. Then if the updated, we go back and test the updated condition. If the updated condition is true, then we are going to repeat the same thing. The task, update the condition, test the condition again. If that condition is true, repeat the same thing, task, update condition, until that condition is what? It's false. If the condition is false, we can get out of the loop. Then we can execute the next instructions. So this is your loop. This is the general, all these loops, they work the same. So if you know one loop, you know every other loop. So yeah, you must make sure you memorize this these loops that we are going to cover here. Then you won't struggle with the remaining material of this course. So we are going to start with the counter controlled while loop. So counter controlled. So this loop is controlled by a what? By a counter. So we are counting and we know how many times the loop will execute. Before we even start the loop, we already know how many times the loop will execute, or the compiler knows how many times the loop must execute. The key thing here is that we know. So this is what they are going to ask. This is there on the semester test. This is going to be there. Definitely you must. We know how many times the loop will execute, so you must know this. Then the steps or the syntax. So you initialize your counter because it depends on the counter. You initialize the counter, then you have this while, then you open, you put the condition just like your if statements. This is it's your Boolean expression. It can either be true or false. So there's no semicolon. Please, there's no semicolon. You have to be careful. Then if the condition is true, we are going to enter the body of the while loop, just as we did with if statements. You see, knowing if statements was very important. If the condition is true, we execute this task. Then we go to the next instruction if the condition is false. So it's sort of like a one-way selection. The if statement, the one we did previously, the if statement only. Because with the if statement, you just say, if it's true, do this. Then you don't have an else and whatnot. You just go to the next instruction. Similar to it, but here we are repeating. So if it's while, then you put the condition. If the condition is true, you execute the body of the loop. So you execute the task, update the condition, then we test the condition again. So this is known as a pre-test. So a while loop, it's a pre-test loop because it tests the condition before it can execute the body of the loop. So from the loops, from those three types of loops, we have the while loop, which is pre-test. Then we have the for loop. The for loop it's a post. It's also a pre-test. It's also a pre-test. Then the do while loop is the post test. Then this one is a pre-test. So the while loop is a pre-test loop, but they won't ask that in the test. Definitely. Maybe unless if they changed. So the execution of the while loop is going to be, you initialize the counter. So you start here, you initialize counter, then you check the condition. Is the condition true or false? If the condition is true, we execute the body of the loop. So we go to the task. Then we do what? We update the counter. So this is important. then we go to the condition again. We test the updated condition. If that condition is true, we are going to repeat the same task until we reach a false condition. Only if the condition is false, we can go to the next instruction. We can exit the loop. So that's it. That's the while loop. We are going to consider an example to further understand. So we are going to go slowly here. No need to rush. So if you are in a hurry, then it's unfortunate, because here you have to take your time. So the first example, so we want to add numbers 1 to 10 to a list box. That's the goal. So I'm not going to do the IPO model here, because this is just theory. The IPO model, you can do that. So the solution, we want to count from 1 to 10. So our counter must start at 1. So with the counter control loop, we have to identify where our counter starts and where it ends. So in this case, it must start at 1, because we are counting from 1, and end where? At 10. So every time we count, we want to add the current counter to a list box. So like, think about it. When you start counting 1, like if you were doing it manually, you were going to say, okay, 1. Let's say you have like items. So you take the first item, it's 1. You put it, let's say, inside a box. Then you take the second item will be what? 2. You take that 2, you put it where? To the box. Then you take 3, you put it to the box. 4, to the box. So your counter will start here. Your counter will start at 1. Next iteration, your counter will be 2. So if it's at 1, it's at 1. Then you add it where? To the list box. Then it's at 2. You add it where? To the list box. Then the counter will move to 3. Then you add it from where? To the list box. The counter will move to 4. You add it where? To the list box, and will move to 5, and you add it to the list box until you reach 10. When you reach 10, you add it to the list box. Then 11. Because we reach 10, we stop. We can't go to what? To 11. So the stopping condition is that your counter starts from 1, 2, 3, 4, 5, 6, 7, 8. So we are just every time we are increasing your counter by 1. So let's see how we can convert this to a loop. So initially we start at 1. So our I is equals to 1. So this is your initialized counter. So yeah, let me just do this. So that's how it works. As easy as that. We'll see how it works in detail. So we start int I equals to 1. That's your initial counter. Then int n equals to 4. This is optional. This is your maximum that you can reach. Then you can write while. So where do we end? I is less or equals to 4. I mean, in this case, I want the max to be 4. Just to avoid, I can say max is 10, but just to avoid like long thing, I will say, okay, let's add numbers from 1 to 4. We want to end at 4. Then every time we just say lst numbers dot item dot add. Then we are adding what? I. Then I plus plus. That's the code. Then let's see how this works. So we start I equals to 1, I equals to 4. If you want, I can be 10, I can be a million. You see the advantage of loops. The only thing that we can change is this I, because it can be million, it can be 10, but this code will be the same. That's the advantage of using loops. Even if n was million, the code was going to be the same. So while I is less or equals to n, so I, we know that it's our counter, while our counter is less or equals to n, because when we exceed the counter, we want to stop counting. So the maximum will be n. We are going to end at n. Then if that's the case, as long as I is less or equals to 4, which is n. We want to add numbers to the list box. If we wanted to stop at 10, this was going to be 10. So this was going to be 10. So then we update the most important. We are adding I, then we update the counter. Let's see how this works. To fully understand this, let's see how this works. So this is the most important steps to know how to execute a loop on paper. So you have to know how to execute it on paper before you can do it manually. You can do it on head, but first, before you can move to that, you have to know how to execute it on paper. So initially when we start, our I is what? Our I is 1. Then what about our n? Our n is 4. In this case it's 4. I forgot to update. If you wanted to start at 10, you were going to put 10, but it works the same. So then we go to the condition. We test the condition. It's I less or equals to n. So our I is 1. So is 1 less or equals to 4? Yes, 1 is less than or equals to 4. This is a true or false. So this is what? This is true. If it's true, we are going to do what? We are going to execute the code. So we are going to say lst_numbers.items.add I. What is our I? At that specific moment, our I is 1. So we are going to add 1 to the list box. Then after adding 1 to the list box, we are going to do what? To increment, to increase I to what? To 2. So our I will be 2. Our n will remain at 4 because there's no code that changes n within the loop. Then because it's a loop, we are not ending, we are going back to the condition. So we are going to test the condition again. In this case, our I is 2, then our n is 4. So we are going to test. It's I less or equals to n. So our I in this case is 2. Is 2 less or equals to 4? Yes, 2 is less or equals to 4. So what are we going to do? We are going to execute the code inside the loop. So we are going to say lst_numbers.items.add I. So in this case, our I is 1. Our I in this case is 2. So we are going to add 2 to our list box. Then we are going to run the next code, which will update our counter. So our I will be updated to 3. N remains the same. Then where do we go after updating? We go back. We execute the condition again. So this will be the third test. So it's I less or equals to 4. In this case, our I is 3. Then our n is still 4. It's 3 less or equals to 4. Yes, that's true. What are we going to do? We are going to execute this line of code. So we are going to add I. What is the I we are adding? It's the 3 to where? To the list box. So our list box will contain numbers 1 to 3. Then what do we do after adding to the list box? We update our I. So we increase I by 1. So our value of I will be 4. Then our n will be 4. Then we have to test again because we updated. After updating, we go back to the condition. We test the condition. It's 4 less or equals to 4? Yes, 4 is less or equals to 4. Where do we go? We go inside the loop. We add the I to what? To the list box. So in this case, our I is 4. So we added 4 to the list box. Then we do what? We run the next line of code. We update. We increase our I by 1. So our I will be 5. So we are going to test again. It's I less or equals to n. In this case, it's 5 less or equals to 5. No, this is false. So we are going to stop executing the what? The loop. Then we are done. As easy as that. When we finish, notice that our I is equals to 5. That's the final value of I. That's the updated value of I. I is not 4. I is 5. The loop stopped working when I was 5. So you have to be careful. So you see the counter was moving from 1, 2, 3, 4 until it reaches the limit. We are just counting. The I It's just moving I. It's going to move from 1, 2, because when we updating it, we are increasing it by 1. So it's going to move to 3, then it's going to move to 4. Then I think you can pause the video and try to execute this yourself. Try to execute this code yourself just to get more practice. Then compare again. Then just repeat. If you don't understand, try to repeat. Then yeah, that's how you execute a loop. That's the most important part, executing the loop manually. Now we are going to focus on the update. So the update can be anything that changes the value of counter. So it's not necessary to put increment, decrement, whether it's a postfix, prefix is not necessary. So it can be counter plus plus, as we saw, increase by 1. It can be counter minus minus, decrease by 1, or it can be plus plus counter, which is increased by 1, minus minus counter, decrease by 1. It can be counter multiply equals to 2. We know this is the same as counter equals to counter multiplied by 2, so it's multiplied by 2. Counter divide equals to 2, it divides counter by 2. Counter plus equals to 3, it increments counter by 3. So you can have different updates. These are not the only updates you can have. So what happens if we don't update counter? So this is an interesting question. So we have to consider I equals to 0. Let's consider this code. I equals to 0. As long as I is less than 2, we want to display a message saying hello. So we know that initially our I is what? It's 0. In this case, we are keeping track. So initially our I is 0. In this case, we just have a fixed 2. So we test, is 0, it's I less than 2. Is 0 less than 2? No, yes, 0 is less than 2, of course. So this will be true. So if it's true, what are we going to do? We are going to execute the body of the loop. So in this case, we are just executing message box.show hello. It's going to display hello on the message box. So we are going to get this hello. Then notice that we don't have any code that updates I, that changes I. So we are not going to change the value of I. I will remain 0. So again, I will remain at 0. Again, is I less than 2? Yes, 0 is less than 2. So we are going to output what? Hello. Then again, I will remain 0 because there's no update. We test for the third time. Is 0 less than 2? Yes, 0 is less than 2. So we are going to execute hello. Then until even case for I, it's still 0. We test. Is 0 less than 2? No. So we are going to execute hello until infinitely, so until your code stops working. So it's an infinite loop. So the condition is always true. There's no update, or if there's an update, the update is always true. It never becomes false. So we call this an infinite loop. So this is a loop that never stops executing. So you have to be careful with infinite loops. We will cover more about infinite loops later. So it's a simple riddle which no one can solve, I guess. So I only stop when your form, here it was supposed to be your form stops responding. What am I? So definitely an infinite loop. So you have to be careful about infinite loops. So yeah, infinite loops, be careful. You will be surprised. Your form stops responding. What happened? It's an infinite loop. Then you have to debug your code. That's why it's important to know how to execute your code manually. So it's very important. So another example, we want to add numbers 10 to 0. So from 10 to 0, but only include multiples of 2. So the solution, we are going to count from 10 So to include multiples of 2, the easy case is to decrease 10 by 2 every time, since 10 is already a multiple of 2. So we can say 10, 8, 6, 4, 2, 0. So our counter will start from what? From 10, and it will end at 0. So again, initialization, I starts from 10. I represents the counter. Then while I is greater or equals to 0, because we want to go in the opposite direction. So as long as I is greater than or equals to 0, that's where we can add the number to what? To the list box, because it's greater or equals to 0. So we know that I will be 10, 8, 6, 4, 2, 0. It won't be 9. It can never be 9 because we are decreasing by 2. So we just adding the I to the list box, then we update the counter. We are decreasing I by 2. So the properties of the loop: initialization, condition, the do something, then the update counter. This do something can be an if statement. It can be like some complicated code. It's not one line of code. It can be multiple lines of code. Then executing or execution. So when we start, our I is 10. In this case, we just have a fixed value, which is 0. Then we test. Is 10 greater or equals to 0? Yes, this is true. Then what are we going to do? We are going to execute this code. We are going to add the current value of I, which is 10, to the list box. Then after that, we do what? We update I. We decrease I by what? By 2. So our I is going to be what? Our I is going to be 8. Then after this, because it's a loop, we are going to test the condition again. So we are going to test if that I, which is 8, is it greater or equals to 0? Yes, 8 is greater or equals to 0. What are we going to do? We are going to add that current value of I to the list box. Then after adding that current value, we are decreasing I by 2. So our I will be 6. So again, we test, because we are from here, last line. So if we are inside the loop, the last line will take us back to the condition always. So we are going back to the condition. We test again. Is that I, which is 6, greater or equals to 0? Yes, that's the case. We are adding that 6 to the list box. Then we decrease I by 2. We know it's going to be 4. Then we test. It's 4 greater or equals to 0? Yes. 4 is greater or equals to 0. We add it to where? To the list box. Again, you can pause the video and just redo the whole thing on your own, just for practice. Then we decrease I by 2. So I is going to be 2. Then we test this: 2 greater or equals to 0? Yes, 2 is greater or equals to 0. We add it to the list box. Then we decrease our I by 2. So I will be 0. Then we test again: is 0 greater or equals to 0? Yes. So we must add that 0 to the list box. We decrease I by 2. So I is going to be negative 2. So we test: is negative 2 greater or equals to 0? No, negative 2 is less or equals to 0. So we stop the loop. So again, pause the video or do whatever and execute the code like on your own. Then here are a few tips on how to avoid infinite loops. So you must make sure that the counter approaches the limit. So make sure that the counter approaches the limit if you want to avoid an infinite loop. Your counter update should, so this was supposed to be just update, should ensure that counter approaches the limit. For example, I equals to 0. The update is I plus plus. So we know that when we start at 0, every time we increase, we are going to reach this condition. So I less than 10 is going to be reached. So the limit is 10. It's going to be reached because we are moving from 0, 1, 2, 3, 4. we are increasing by 1, we are definitely going to reach 10. But let's say we have I equals to 0, then I minus minus I less than 10. Notice that I is not approaching 10 because we are decreasing it. I is going the opposite direction. So this condition can never be false. It's always going to be true. So this will result in what? In an infinite loop. We will cover more infinite loops, like more examples on other sessions. Or in-person sessions, not on the video section, because this is the last video, which is not nice, I guess. Then another example. So now we are moving to a problem, sort of not the real problem, but the problem. So given a data set from a list box, write a code that will calculate the mean. So we know from statistics that the mean, which is your x bar, is equals to the summation from 1 up to the number of elements. Then you just add the sum of those elements, then you divide it by the number of elements. In simple terms, it's the sum of individual elements over the number of elements, or you can use mathematics whatever way. When you see sigma in programming, sigma represents what? Represents a loop, which is interesting. It represents a loop, so it's very interesting. Then solution, we have to think about it. Let's just think, we simplify the problem. Let's say we know that we can get as many items as possible. So let's simplify the problem and say we have 1, 2, 3, 4, 5, 6 items. We know that in Visual Studio Code is going to be represented like this, but in memory we have a list of items. So LST data. So we know item 0 refers to the first, items 1 refers to the second, items 2, and so on. That's why we covered the list box. So the first attempt, the BET approach. So this is the BET approach. So okay, let's say, okay, with the BET approach, we are going to say, okay, the sum is equals to, this is the same as convert to int 32. For you guys, use the convert to int 32. Don't use this casting. This is casting, sort of converting. But you use convert to int 32. So we are going to say, okay, we are going to take our lst data.item 0. We know that it's going to refer to the first item. Then we convert that to an integer. Then we take the second item. So lst data.items 1. So it refers to the second item. We convert it to an integer. We take that, like we sum them one by one. So this is perfect. Honestly speaking, then we say sum equals to x over 5, or the number of items. This is, which is 6. So sorry, this was supposed to be 6. This is perfect, but the problem is, what if we had 1 million items? What was going to happen? We were going to write like this plus until 999,000, then 999. Just imagine this plus until that a million times, sort of. So this is not good. So the appropriate solution will be using loops. So we know that from this we started 0, counter started 0, 2, 0, 1, 2, because this is positioning, so it starts at 0. So it's going to be 0, 1, 2. We want counter to start here, then go 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 here. So this seems much better. So how can we do that? So our count will start at 0. Then we have the sum which starts at 0. We know that to add things, we are going to say, okay, our sum is equals to 10. Next iteration, we say, okay, sum equals to 10 plus 20. We can add to the current sum. I'm sure you remember that concept of global variables, but now we are not going to use global variables, which is interesting. I remember for that, I don't know if it was practical 3, those guys who did IT were using loops, even though it was not appropriate to use loops then, since they didn't teach that. But now you will see how it works with loops. You can actually add the sum of numbers in the list box using your loops. So we are going to start. Okay, we know sum initially 0, x, not necessary to initialize it. So while what is our stopping condition? We know we are going to count from 0, 1, 2, 3, 4, 5, but we don't know the number of items. Then how do we get the number of items in the list box? Because this can be 4, this can be 6, this can be 10, this can be million. That's why we use that let me see, that LST count. So you see LST, this is the name of the list box, .items.count. As long as our I is less than that size, the number of items in the list box, then we are good to go. We just say sum plus equals to, you can use the convert to int, then lst data.items, then you put the index, then I plus plus. This concept is not easy to do it like with a video. It's easier in person. So if you don't understand, I understand why you don't understand, because it's not easy. Because here I'm just reading, which is not good. In person, I would write this down like step by step and show you how everything works, but just try to hang in there. So yeah, this is the loop. We are going to start at 0. Then as long as that I is less than the size or the number of items, we just say sum plus equals to, here you can use convert to int32. Then how do we access an individual item? We just say lst data dot items at I, then we just say I plus plus. Then let's see how it works. Then after calculating the sum, remember from the formula, that's formula, you first calculate the sum before you can calculate the average. Then you calculate the average. So this sum, it's your loop. So you see this average, it's not inside the loop. So normally beginners make a mistake of putting the average inside the loop. So it's not inside the loop. You have to be careful. So let's try to execute this loop. So our I is going to start, initially I is 0, the sum is 0, x is 0, which x is not that necessary. Then we have this list box initially, so with the data. Oh, we are back. So my PC just turned off like while recording, so my battery was low. So I don't know how it affected the recording, but I was doing this while loop. So we were executing the loop. I said initially our I is 0, sum is 0, x is 0. So we are going to test the condition. Is I less than lst data.items.count? In this case, how many items do we have? 1, 2, 3, 4, 5. That's the items.count. So we are going to have 5 items. So it's 0 less or equals to 5. Yes, 0 is less or equals to 5. So our sum, we are going to execute this line, sum plus equals to, we are going to add to the previous sum. Our previous sum was 0, so we are going to add whatever, add 0. So our I is 0, so we are going to add items 0, whatever. So it's this 10. So sum is equals to 0 plus 10, which is 10. Then after executing that line, we are going to increase our I by 1. So our I is going to be 1 from 0 to 1. Then we test again the condition. Because it's a loop, we go back to the condition. We check, is 1 less or equals to, is 1 less than 5? Yes, 1 is less than 5. Then we execute that code, sum plus equals to whatever. Now I it's 1. So at 1 we have this 20. So we are going to say sum is equals to the previous sum, which is 10 plus 20. So it's going to be 30. Then we are going to increase our I by 1. So our I was going to be 2. So we are going to test the condition. Is 2 less than 5? Yes, 2 is less than 5. We are going to execute sum plus equals to whatever. In this case, our I it's what? It's 2. So at items 2, we have what? We have this 30. Remember, this is 0 in terms of position 1, 2, and 3, and 4, something like that. Then we have sum will contain what? It will contain, so our initial sum was 60. Now when we add, it was 30. Now when we add 30, it's going to be what? It's going to be 60. Then we are going to do what? Increase our I. So our I is equals to, it's going to be 3 because we are increasing it by 1. Then we test, is 3 less than 5? 3 is less than 5. We are going to add sum at 3. So at 3 we have 40. 60 plus 40. Previous sum was 60 plus 40. It's going to be what? 100. Then we increase I by what? By 4. Then we are going to say, we are going to increase the I to what? To 5. actually to 4. Then we test the condition again. Is 4 less than 5? Yes, 4 is less than 5. We are going to add to the previous sum at index 4. So items at index 4, it's 50. So it's going to be 100 plus 50, which is 150. Our I, it's what? It's 5. Then now, is 5 less than 5? No, I didn't write that. Oh, I did. So we are going to do what? Stop the loop. Then here we are going to get, okay, sum, the average equals to sum over lst_data.items.count. So we know that this will return 5 since we have 5 items. So it's going to be 150 divided by 5, which is 30. So this is going to be the average if I calculated it correctly. But yeah, it should range somewhere there because the maximum is 50. Yeah, it should be 30 if you calculate it manually. So we successfully calculated the average. Again, try to execute the loop on your own, then you will be fine. Just follow the same steps. Just keep track of the initial values, then you test, then update the values. Now we can move to the last part of the loop, since I said I'm going to do the first 3 parts, not everything. So the last part will be the sentinel controlled or the indefinite loop. So the repetition is not based on a counter but some condition. So the important property is that we don't know how many times the loop will execute. With a counter controlled loop, the fact that we have an initial point and a terminal point, we know how many times the loop will execute. But with this one, we don't have those. So an example, write a code that will search for a specific text in a list box. So given a text, we want to check if that text is there on a list box. Then how can we do that? We go to the IPO, but I won't go into detail. So we are receiving the text from the user, then the logic, then the output, it's found or not found. So if we found the text, we're going to say found. But if we didn't find the text, we are going to say not found. So again, we declare string text is empty, output is empty, I, it's our counter starts from 0. Even though we don't necessarily, yes, we do need a counter, but not that much. It doesn't depend on the counter that much. You can check your lecture slides for other examples. Then we have n equals to 0. So n will store the size. It's not necessary, but I just put it there. So n is equals to lst texts.items.count. So it's going to store the number of items in the list box. It's not that important, but yeah. Then text equals to txt, and lst text the items.count returns an integer always. So there's no need to convert because I have an integer, then integer. Then text equals to txt.text. This is a string. Also, this is a string, no need to convert. So we are storing this text, the one we get from the user, to our what? To the list, to a variable. Then the code will be while I is less than n. We know that n is the number of items and text is not equals to lst text, then you say I dot to string. So let's see how this works. Then we just increment I. So we know that let's say we were searching for AA, for CCC. So for CCC, we know that we are going to compare CCC with A. Are they equal? No. So we are going to move to the next item. So we compare, is this equals to this? No. Is this equals to this? Yes. We stop. So the loop will stop only if they are equal. That's why we said while this is not equals to this, we repeat. So we compare, are they equal? No. That's why we say while this is not equals to this. If it's not equal, we continue. If it's not equal, now is C equals to C? Yes, they're equal, so we can stop. Then let's say we were searching for triple F. So we are going to start, is F equals to this A? No. So we continue, is F equals to this? No. Is F equals to this? No. Is F equals to this? No. If is F equals to this? No. But we don't know how to end here. We will try to compare with something that is at index 5, but we only have 5 items. We cannot go to index 5, so our code is going to crash. So to avoid this, we have to ensure that we have a counter that will start at 0 and it must end at that size of the list box. That's why we have this I less than n. This is to ensure that like we reach the end of that list box. Then we just say end. This means while our counter is less than the size of the list box and we did not find the text actually, then we just keep updating, moving down. Then we just compare. Then after, how do we determine if we found the text? So if I is equals to that lst.items.count here, or the size of the list box, that's where we can say we didn't find that because our I exceeded the maximum index. So this is not easy to explain on a video. It's easy to explain in person actually, because on a video it's very difficult. It's not easy. So I'm having a difficult time explaining this on a video, so you'll forgive me when it comes to that. Yeah, but you just check if that I it's equals to the size of your list box, then we exceeded. This means we didn't find the element, so that's why we said otherwise we did find the element. So let's see the execution with the above example. So in this case our text will be this CCC, then the list box will contain this. Then let's see execution. So initially I equals to 0 and equals to 5 because we have 5 items. Text equals to CCC, the one we got from the text box. Then we test, is 0 less than 5? Yes, it's that one of I less than n. And is CCC not equals to A? Yes. So this is true. We can execute the body of the loop. So the body of the loop says increment I. That's all, nothing else. Then our I will increase from 0 to 1 actually. Then we are going to compare again. It's 1 less than 5. It's I less than n. Yes, I is less than n. And is C not equals to B? Yes. So this is also true. So we are going to execute the body of the while loop, which is just incrementing I. Then we reach the third case. It's 2 less than 5 and C not equals to C. 2 is less than 5, we agree, but C not equals to C.